Everything you've been taught about the speed of light is wrong. You think it's just a really fast speed, the cosmic speed limit that nothing can exceed. But Stephen Hawking discovered something that will shatter your understanding of reality itself. The speed of light isn't actually a speed at all. It's something far more fundamental and terrifying, something that reveals the true nature of space, time, and existence itself. What if I told you that light doesn't move through space, but that space itself moves through light? What if the speed of light isn't about motion, but about the rate at which reality itself unfolds? Hawking's final insights into the nature of light revealed that we've been looking at the universe completely backwards, and his discovery could explain everything from why time exists to how consciousness itself emerges from the fabric of space-time. This isn't just physics anymore. This is about the fundamental structure of reality, about why you experience time flowing forward, why you can't travel faster than light, and why the universe has the specific properties that allow life to exist. Hawking realized that the speed of light is actually the speed of causality itself, the rate at which cause and effect propagate through the universe. Before we dive into this reality-shattering revelation that could rewrite everything we know about the cosmos, hit that subscribe button because we're about to explore the most profound secret hidden in plain sight. Stephen Hawking's revolutionary understanding of light began with a simple but profound question. Why does light travel at exactly 299,792,458 meters per second and not some other speed? This number seems arbitrary, but Hawking realized it's actually the most fundamental constant in the universe, more basic than gravity, more essential than the mass of particles, more crucial than any other physical property. The physicist discovered that what we call the speed of light isn't really about light at all. Light just happens to travel at this speed because it has no mass, but the speed itself represents something far more fundamental, the maximum rate at which information can propagate through space-time. This is the speed of causality, the rate at which cause and effect can spread through the universe. Think about what this means. When you flip a light switch, the effect doesn't happen instantaneously throughout the room. The information that the switch has been flipped propagates outward at the speed of light, and only when that information reaches each part of the room does the effect occur there. Reality itself unfolds at the speed of light, with each moment of the present expanding outward like a sphere, bringing the future into existence. Hawking realized that this isn't just a quirk of physics, but the fundamental mechanism by which time itself works. Time doesn't flow like a river carrying us along. Instead, the present moment expands outward at the speed of light, converting potential futures into actual reality. The speed of light is literally the speed at which time moves through space, the rate at which the universe updates itself from one moment to the next. This led the physicist to a startling conclusion. Space and time aren't separate things that light moves through. Instead, space-time is a dynamic structure that unfolds at the speed of light, and what we perceive as the motion of light is actually the expansion of reality itself. Light doesn't travel through space. Space travels through light, unfolding moment by moment at the cosmic speed limit. But here's where Hawking's insight becomes truly mind-bending. If the speed of light is the rate at which reality unfolds, then nothing can travel faster than light, because there is no faster than the rate of reality itself. You can't outrun the expansion of the present moment because you exist within that expansion. Trying to exceed the speed of light would be like trying to arrive at tomorrow before tomorrow exists. The physicist understood that this reveals why the speed of light is constant for all observers, regardless of their motion. It's not because light has some special property that keeps its speed fixed. It's because the speed of light is actually the speed of space-time itself. No matter how fast you're moving, you're always embedded in the same expanding structure of reality, so you always measure the same rate of expansion. This explains one of the most puzzling aspects of Einstein's relativity, why time dilates and space contracts for objects moving at high speeds. As you approach the speed of light, you're approaching the rate at which reality itself unfolds. Time slows down for you because you're moving closer to the fundamental time-keeping mechanism of the universe. You're synchronizing with the cosmic clock that ticks at the speed of light. Hawking realized that this has profound implications for our understanding of mass and energy. Mass isn't just stuff that has weight. It's a form of resistance to the expansion of space-time. Massive objects can't reach the speed of light because they create distortions in the space-time fabric that prevent them from keeping up with the rate of reality's expansion. The more massive an object, the more it warps space-time, and the more it lags behind the cosmic update rate. But massless particles like photons don't create these distortions, so they naturally move at the speed of space-time expansion. They're not really moving at all in the conventional sense. They're simply riding the wave of reality as it unfolds. Light is the universe showing us the rate at which existence itself propagates through the cosmos. This led Hawking to an even more radical insight. Energy and mass are different ways of measuring how much an object resists the natural expansion of space-time. Einstein's famous equation, E=mc2, isn't just about converting matter to energy, it's about the relationship between resistance to space-time expansion and the fundamental rate of that expansion. The speed of light squared appears in the equation because it represents the rate of reality's unfolding multiplied by itself. The physicist also realized that this explains why the universe has a maximum speed limit at all. In a universe where space-time unfolds at a finite rate, there must be a maximum speed because you can't move faster than the rate at which new space-time is being created. The speed of light isn't a speed limit imposed on objects moving through space, it's the rate limit of reality itself. But here's where things get really strange. If space-time unfolds at the speed of light, then what happens at the boundary where new reality is being created? Hawking speculated that this boundary might be where quantum effects become dominant, where the smooth fabric of space-time breaks down into the quantum foam of virtual particles and uncertainty. This could explain why quantum mechanics seems so different from classical physics. At the scale where space-time is being created moment by moment, the normal rules of causality break down, because cause and effect are still in the process of being established. Quantum uncertainty might not be a fundamental property of matter, but rather a consequence of observing reality at the edge of its own creation. Let me ask you something that might change how you think about your place in the universe. If reality unfolds at the speed of light, and you're always embedded in this expanding present moment, what does that say about your experience of time and consciousness? Are your thoughts and awareness part of the mechanism by which the universe updates itself? Share your thoughts in the comments below, because the answer might reveal something profound about the nature of consciousness itself. Hawking's understanding of light as the speed of reality also has implications for black holes and the nature of information. Near a black hole's event horizon, space-time becomes so warped that the rate of reality's expansion slows down dramatically. Time dilation near black holes isn't just about gravity affecting clocks, it's about gravity affecting the fundamental rate at which space-time unfolds. At the event horizon itself, the expansion of space-time comes to a complete stop from the perspective of outside observers. This is why objects falling into black holes appear to freeze at the horizon. They're not really slowing down, but the rate of reality's expansion at that location has dropped to zero. The black hole creates a region where the cosmic update mechanism breaks down entirely. The physicists speculated that this breakdown of space-time expansion might be where information gets encoded on the black hole's surface. If reality can't unfold normally near the event horizon, then information about objects falling in might get stored in the boundary between the expanding and non-expanding regions of space-time. This holographic storage of information could explain how black holes can have entropy and temperature, despite being classical objects in general relativity. The information isn't stored inside the black hole, but on the boundary where the normal expansion of reality breaks down. The black hole's surface becomes a cosmic hard drive, storing information in the structure of space-time itself. Hawking also explored how this understanding of light changes our perspective on the Big Bang and the origin of the universe. If space-time unfolds at the speed of light, then the Big Bang wasn't an explosion in space, but rather the beginning of space-time's expansion itself. The universe didn't start with a bang and then expand. The expansion is the universe, and the Big Bang was the moment when this expansion began. This means that the edge of the observable universe isn't a place, but a time. When we look at distant galaxies, we're seeing them as they were when the light left them, but we're also seeing the universe at an earlier stage of its expansion. The cosmic microwave background radiation isn't just the afterglow of the Big Bang, it's the boundary of space-time expansion itself, the edge of reality as it unfolds. The physicist realized that this has profound implications for our understanding of cosmic inflation, the rapid expansion of space that occurred in the universe's first moments. Inflation wasn't just space expanding faster than light, it was the rate of reality's expansion temporarily accelerating beyond its normal speed. The universe was updating itself faster than usual. creating more space-time per unit of cosmic time. This could explain why inflation ended when it did. The expansion rate of reality has natural limits based on the fundamental structure of space-time. When inflation pushed beyond these limits, quantum effects kicked in to restore the normal expansion rate, ending the inflationary epoch and beginning the more sedate expansion we observe today. Hawking's insights also shed new light on dark energy, the mysterious force that's accelerating the universe's expansion. If space-time naturally unfolds at the speed of light, then dark energy might not be a force at all, but rather the natural tendency of reality to expand. The acceleration we observe might be the universe returning to its natural expansion rate after being slowed down by the gravitational effects of matter and energy. This would mean that dark energy isn't something added to the universe, but rather the default state of space-time expansion. Matter and radiation slow down this expansion through their gravitational effects, but as the universe expands and matter becomes more dilute, the natural expansion rate reasserts itself, leading to acceleration. The physicist also considered how this understanding of light affects our perception of simultaneity and the nature of now. If reality unfolds at the speed of light, then events that are simultaneous for you might not be simultaneous for someone moving relative to you. This isn't just a quirk of measurement. It reflects the fact that the expansion of reality itself depends on your reference frame. Your now is defined by the sphere of space-time expansion centered on your location. Events outside this sphere haven't happened yet from your perspective because the expansion of reality hasn't reached them. Someone moving relative to you has a different sphere of expansion, so their now includes different events. There's no universal now because there's no universal rate of space-time expansion. This relativity of simultaneity has profound implications for free will and determinism. If the future doesn't exist until reality expands to include it, then the future might be genuinely open and undetermined. Your choices might not just reveal a predetermined future, but actually participate in creating that future as space-time unfolds. Hawking speculated that consciousness might play a role in this process. If observers can influence quantum measurements, and if quantum effects are related to the edge of space-time expansion, then conscious beings might participate in the mechanism by which reality unfolds. Your awareness might be part of the cosmic update process that converts potential futures into actual presence. But the physicist also recognized the limits of this analogy. Space-time isn't really like a computer updating itself, and reality isn't really unfolding like frames in a movie. These are just metaphors to help us understand something that's fundamentally beyond our everyday experience. The true nature of space-time expansion might be something we can describe mathematically, but never fully visualize or comprehend. Recent experiments in quantum optics have provided some support for Hawking's ideas about the fundamental nature of the speed of light. Studies of quantum entanglement show that information can be correlated across vast distances instantaneously, but no usable information can be transmitted faster than light. This suggests that the speed of light really is a fundamental limit on information transfer, supporting the idea that it's the speed of causality itself. Research into the quantum vacuum has also revealed that empty space isn't really empty, but filled with virtual particles that pop in and out of existence. These quantum fluctuations might be related to the mechanism by which space-time unfolds, with virtual particles representing the quantum uncertainty at the edge of reality's expansion. The physicist's work on the nature of light also connects to his theories about the holographic principle and the storage of information. If space-time unfolds at the speed of light, and if information about three-dimensional volumes can be stored on two-dimensional boundaries, then the expansion of reality might be the process by which holographic information gets projected into three-dimensional existence. This could mean that what we perceive as the flow of time is actually the projection of holographic information from the boundary of space-time into the three-dimensional world we experience. The speed of light would be the frame rate of this cosmic projection, the rate at which holographic information gets converted into three-dimensional reality. Hawking also explored how this understanding might apply to the multiverse and parallel universes. If each universe has its own rate of space-time expansion, then the speed of light might be different in different universes. Universes with faster expansion rates would have higher speeds of light, while those with slower rates would have lower speeds. This could explain the fine-tuning of physical constants in our universe. The speed of light isn't arbitrary, It's determined by the fundamental structure of space-time in our particular universe. Other universes with different structures would have different speeds of light, leading to different physics and different possibilities for complexity and life. Stephen Hawking never lived to fully develop his revolutionary understanding of light as the speed of reality itself, but his insights point toward a radically new way of thinking about the universe. Light isn't just electromagnetic radiation traveling through space. It's the manifestation of space-time's fundamental expansion, the visible evidence of reality unfolding moment by moment. The physicist's legacy in our understanding of light extends far beyond physics into philosophy and the nature of existence itself. If the speed of light is the speed of reality, then every photon carries information about the fundamental structure of the universe. Every beam of light is a message from the cosmos about the rate at which existence itself propagates through space and time. So the next time you see light, remember that you're not just seeing electromagnetic radiation. You're witnessing the expansion of reality itself, the cosmic mechanism that converts potential into actual, future into present, possibility into existence. Light is the universe showing you the rate at which it creates itself, moment by moment, at the speed of causality. The implications are staggering. If Hawking was right, then the speed of light isn't a speed limit, but the speed of existence itself. Time doesn't flow, it expands. Space doesn't contain motion, it participates in it. Reality doesn't just exist, it unfolds, moment by moment, at exactly 299,792,458 meters per second. This means that every moment of your life is part of the cosmic expansion of reality. Every thought you think participates in the universe's ongoing creation of itself. You're not just observing the universe, you're part of the mechanism by which it unfolds, a conscious participant in the greatest process in existence, the moment-by-moment creation of reality itself. If this exploration of Stephen Hawking's revolutionary understanding of light has completely transformed how you see the universe around you, make sure to smash that like button to support more mind-bending revelations about the true nature of reality. Subscribe to our channel and hit that notification bell so you never miss our latest discoveries about the fundamental mysteries that govern existence itself. Share this video with anyone who's ever wondered why light travels at the speed it does, because this insight could change everything we think we know about space, time, and the nature of reality. And let me know in the comments. If the speed of light is really the speed of reality unfolding, how does that change your understanding of time, space, and your place in the universe? Do you think this explains why we experience time flowing forward, or why quantum mechanics seems so strange at the smallest scales? What would it mean for humanity if we could somehow influence the rate at which reality expands? Drop your thoughts below and join our community of reality explorers as we continue to uncover the deepest secrets hidden in the fabric of space-time itself. The true nature of light and reality is waiting to be discovered, and with your support, we're just beginning to illuminate the most profound mysteries of Stephen Hawking's cosmic insights.